Hello, good afternoon. So today I will show how to do the task sheet that we had from last time for projectile motion. So we have here the task sheet, the objectives, the materials, the procedure, and then we have the data and observation table, as well as some handy formulas on the side. You will have to note this or copy this since this is not on your task sheet. So in your data and observation, specifically this video will help you find the data that you need to gather, the distance, the horizontal velocity, initial velocity, and theoretical distance. So, as you recall last time, you brought spray bottles to class. These spray bottles, since I cannot video properly, I'll be using a simulator instead. So you can think of this cannon that I'm using as your spray bottle. So recall last time that when I asked you to spray that it had to be at 0 degrees, meaning it is flat along the horizontal, and the cannon or the spray bottle is a certain height above the ground. So that height is always in meters. For example, for your group, you might have 30 centimeters. If that's 30 centimeters, you'll have to make it 0.3 meters. If it's 25 centimeters, you'll have to make it 0.25 meters. So I'll just show you how to do it using this simulator as my example of my spray bottle. So, remember that last time I asked you to fire with your spray bottle a certain height above the ground. In this case, my cannon is at 7 meters above the ground. So when I measure how far it shot from the base to the area where the water landed in, it will be 15.5 meters. So let me quickly put here 15.5 meters. Once again, do not put 20 centimeters or something. Convert it into meters, like so. So now that we have that, the distance, we need to find our horizontal velocity. And remember, horizontal velocity or velocity is equal to distance over time. So we have our distance, we have no time, but we have the time formula. The formula for time, using these examples, is the square root of 2 times height over gravity. So if I go to my calculator, time is equal to the square root of 2 times height or h over gravity or g. So that's my time formula. So if I actually input that, if I look at my height once again, I put 7 meters. For you, your height might be 0.3 meters or 0.4 meters. So I'll put here 7 meters. And then, my gravity is 9.81. So if you look at that, that would give me a time of 1.19 seconds. So I can put here, let's say my time is equal to 1.19 seconds based on this formula. So since my time is 1.19 seconds, I can now find velocity, which is equal to distance over time. So I can put my distance. What's my distance again? 15.5 meters. So I can put 15.5 meters over my time, 1.19. And that will give me 13.025 meters per second. Or I can just make it 13. I can simplify it to one decimal place, so 13.0 meters per second. So this is how you would find your horizontal velocity. You'd get your distance, and you would find time, and then using the velocity formula, which is, once again, velocity is equal to distance over time. So that's 13 meters per second. And if you look at it, 13 meters per second is actually my initial speed that I put here. So my calculation is correct. So, once again, to find velocity, distance over time, that is time. And to find distance, you just have to measure. To find time, we use this formula. And our horizontal velocity is the same as our initial velocity. Because this horizontal velocity is the cannon's initial velocity. So next, we can now find theoretical distance at 30 degrees. So theoretical distance at 30 degrees. So what is at 30 degrees? What is at 45 degrees? What is at 60 degrees? That is theoretical. Theoretical meaning this is when we calculate it. When we actually do it, it might be different. So, for example, now when I put it at 0 meters above the ground, so for this final step, you'll have to put it at 0 meters above the ground, so it's on the surface. So at 30 degrees, at 45, and at 60. So when you look at it, this is where it should land. And I'm not going to measure it yet. When I measure it, that's the experimental. First, I'm going to calculate it. Calculating will be our theoretical distance. We will calculate it with a formula. And our formula here is range, or R, this is the theoretical distance, is equal to velocity squared times sine 2 theta, theta meaning angle, over gravity. So let's just put it in our calculator. So range or distance will be equal to velocity, let's just put V. V for velocity, multiplied by sine 2 of the angle. So I can't put the angle symbol, so I'll just put angle here, over gravity. So, when we want to find, for example, for 30 degrees, I will put velocity initial squared. So what's my velocity initial? It's 13 meters per second. This is my velocity initial. For you, it will be different, but for me it's 13 meters per second. I will square it. I will multiply it with sine. So multiply it with sine 2 of the angle. So 2 times my angle is 30 degrees over gravity. Remember, the 2 and the 30 degrees should be together in the parentheses. If I put the 2 outside, or if I put the 2 here, I will get a wrong number. It needs to be inside. So 2. So it says that at 30 degrees, my distance should be 14.9. Once again, I'm only using one decimal point. So it says that this should be 14.9 meters. Then to find for 45 degrees, it's very simple. I just need to change this to 45 degrees. And it says I'll get 17.2 meters. So let's put 17.2 meters. And then at 60 degrees, so I'll put 60 here. That says I should get 14.9. So another 14.9. This is my theoretical distance or my calculated distance. But is it the same as my experimental? Experimental is when you actually fire it with your water gun. So after you get your theoretical, you do the experimental or the actual, in which you actually do it. So in my actual here, let's do 30 degrees. And when I fire it, when I measure it, oh, it's actually at 14.9 meters. Is that the same as my theoretical? Yes, because I'm using a simulator. If I put it at 45 degrees, and I measure it, what do I get? I get 17.2, which is the same as my theoretical. So my theoretical, 17.2. I also got 17.2 in my actual. So this actual here would be you firing with your water gun or cannon and then measuring where it lands. So I would fire it, and then I'd measure that it lands here, another 14.9 meters. So this is how to find the theoretical distance and the experimental. Theoretical meaning you calculate it, experimental meaning you actually do it. If you look here, my experimental is the same because I used a simulator, but if you actually do it in real life, you might get, let's say, 12 meters, maybe 13 meters. You might get a different number in real life due to the effects of differing velocities or maybe even air resistance. So for theoretical, once again, just calculate it. For experimental, you have to do it in real life. So this is just how to do your lab report, and we hope to see you soon, and we hope to compare answers. So once you get your data and observations here, just answer the next questions. For example, if you have a difference between your theoretical distance and your experimental, why do you think there's a difference? And so on and so forth. But in this video, we just showed you how to find the data and observation here. So we hope you learned a lot, and God bless.